So this is an addendum to section 4.3, and the book gave you one proof, and I kind of skipped it because I wanted to show you another proof. And I've also formulated, I think, 4 mathematical reasoning questions that are pretty straightforward that I feel you'll see most certainly on the Canvas version on the exam on Chapter 4. So I'm just going to read through this. The textbook does not give a proof for why no number y satisfies the equation 0 is equal to b to the y, and where b is greater than 0 and not equal to 1. So I'm going to provide you one. So this is a proof, and I've got to explain to you how the proof goes. And the proof I'm going to use is called a proof by contradiction. We assume something is actually true. And here's the kind of the weird thing about it is we assume the thing that we want to be proved to be true. We assume that it's actually false. And then we work on the assumption that it's actually false, and then show that that assumption is impossible. So if the assumption that something is false is impossible, then that assumption has to be true. And that type of proof is really popular for people who learn how to use proofs for the first time in an advanced undergraduate course. Usually math majors. Any math major has to learn that. These proofs are called proofs by contradictions. In logic class, they're sometimes called indirect proofs. In the ancient times, they were called reductio ad absurdums. There are some famous reductios, or reductio ad absurdum proofs, found amongst both ancient and medieval philosophers, and they're very popular to this day, and I'm going to give you one right now. So this is the proposition that I actually want to prove, and I'm going to prove it by contradiction, and I'm just going to work my way through it. You don't have to memorize this at all. I would like you to be able to try to understand it, but no memorization. It's not going to be required that you regurgitate it. I mean, after all, you're at home. What good would that do? Because it's right there in front of you. I can't be with you when you're taking your test at home. So here we go. This is the proposition we're going to prove. Suppose b is greater than 0 but not equal to 1. Then there does not exist any real number y such that 0 is equal to b to the y. So here's my proof of what this is. Proof by contradiction. So I'm going to suppose to the contrary that this is actually true. That for b greater than 0 but not equal to 1, there does exist a real number y such that 0 is equal to b to the y. So I assume the very thing I want to prove true, I assume that it's actually false. So now what follows are the implications of that assumption. So I say let n be any real number except minus y. Then b raised to the power of y plus n, using just easy properties of exponents, is equal to b to the y times b to the n. But we've assumed b to the y is equal to 0, so that's equal to 0 times b to the n, which is equal to 0. Okay, so if I let n be any real number except minus y, then if I take my base b and I raise it to y plus n, I still get 0. Interesting. Now I observe that since any real number x can be written as x is equal to n plus y for the appropriate choice of n, this implies that b to the x is equal to 0 for every real number x, except x is equal to 0. And why is that? Because we've excluded n is equal to minus y. And if n is equal to minus y, then minus y plus y is equal to 0. So x is excluded. That value of x is excluded, which is to say that f of x is equal to b to the x is a constant function. But it was an exponential function. Is a constant function with domain minus infinity to infinity. So minus infinity to 0, union 0 to infinity. It's a constant function whose domain is all the real numbers except 0. And whose output, the constant value, is always 0. So this is our contradiction. This contradicts the known fact that f of x is equal to b to the x is an increasing function or a decreasing function whose domain is all of the real numbers. Hence, our original assumption that such a y exists such that 0 is equal to b to the y cannot be true. Therefore, there does not exist any number y such that b to the y is equal to 0. So that's an algebraic proof of what we tried to find out earlier, that no number y exists such that b to the y is equal to 0. So this is at the very, very last page of section 4.3 notes. And I invite you to read through it and go line by line and make sure you understand each step. Feel free. I will probably put something in Piazza to discuss this. No one's discussing anything, but I might do it anyway. So here we have 3 challenge questions. So I'm just going to read them. Explain why the statement, since any real number x can be written as n plus y for the appropriate choice of n, is true by solving the equation x is equal to n plus y for n. Here y is understood to be a fixed number. Y is a constant. So that's really easy to do. I literally tell you what to do. Challenge 2. The contradiction discovered above came about by concluding that f of x is equal to b to the x is a constant function, which is inconsistent with what we discovered in section 4.2 that states that f of x is equal to b to the x is an increasing function or a decreasing one. But I could have actually chosen another type of contradiction. There are other types of contradictions we could have shown. Can you think of another one? And I know you're saying, heck no, I can't think of another one. I don't even understand what you're saying right there. That's okay. That's the reason you reread it and you think about it. I give you a hint. Suppose you let n is equal to 1 minus y. Compute the value of b to the y plus n when n is equal to 1 minus y. Do you get the answer 0? If you don't get the answer to 0, you found a contradiction. Challenge 3. This is probably the hardest one, but I kind of explained it to you earlier. What was the reason for the statement, let n be any real number except minus y? Why did I have to exclude the value minus y is what I'm asking. Hint, use the negative exponent rule and what we know about division by 0. And it's going to happen right here, right there. So if b to the y is equal to 0, what is b to the minus y? Well, that's 1 over b to the y. And that should be plenty enough of a hint. Didn't use that, so that's it for this. Just let me know if you have questions.